Hi everyone, this is Rashid. Today we will talk about different type of chips available and how we differentiate between them on their usage. So look at the first half of it. Okay. A microprocessor is a CPU with some on-chip memory. Microcontroller, I consider microcontroller an SoC, I think, because it has a CPU, it has on-chip memory, but it has also some other controllers that enables microcontroller to act as a complete system. It can interface with other input and output external devices and then has CPU and memory to perform the whole operation for the system. Then there are DSPs processors, again CPUs with on-chip memory, and their instructions are targeted excuse me, their instructions are targeting signal processing. Then we have graphics processing units and instructions on or the internal architecture of the GPUs is targeted for graphics, images, videos. We can also have chips that are created for certain targeted applications. For example, power management ICs, sensor chips, or chips where they still have a CPU on inside, but that CPU is very customized for a special algorithm or a special domain like AI. FPGAs are another type of computer chips. We will talk a little bit how to use them over here. What are FPGAs? Then memory chips. We know that those are memories. System on chip gave a little bit hint of that under microcontroller, but system on chip has a CPU, has a memory, and then has the ability to interface with different external devices, keyboard, mouse, USB, display, or some other special sensors. It's like a complete system on chip. It's not just a CPU. How do we use these chips? It is important, in my opinion, as a chip designer to understand how your clients are going to use them. So, if you take an example of a fixed CPU architecture, when I say a CPU architecture, think of that you have a chip that has a CPU in it. That CPU is made for certain instructions. Those can be uh, arithmetic instruction, addition, multiplication, division, can be logical and or can be shift, can move, then move from memory, move from here and there. But it's like a internal architecture or CPU architecture or CPU plus memory architecture allows you to do smaller operations. And those smaller operation are instructions. Then the software person can use those different instruction in a different sequence for different applications. Key thing is you're not changing internal structure of the CPU. This is very flexible computer architecture. CPUs, and we will study that. CPU structure, its internal components, its interaction with the memory, the whole system allows you to write different software for different application, yet same hardware on the chip. And that's the flexibility that is so important. Otherwise, if you make a chip for one application, maybe that application changes. I mean, things change so much so quickly. And having a chip that is very dedicated for it, yeah, maybe you're taking that risk. You will be really good in that field, but you won't be able to use that chip for much longer. So that whole CPU, memory, instruction, software, that type of thing, that whole computer architecture is super useful. And that's why you see that prevailing in all kind of CPUs, GPU, DSPs, even in ASIC, yeah, ASIC CPUs or ASIC for AI and other applications, okay, or system on chip. So that's a structure you will see a lot. Then, as I just gave you a hint, an opposite is a CPU. Okay, you can think of that. Okay, those are smaller operation, atomic operations, instruction that are executed, but it takes time. Okay, you pull it from the memory, you bring it, you decode it, you execute it, you write back, you update register or memory, and this and all that. So each program can take a lot of time. There is a flexibility, but that is at the cost of performance. It will take certain cycles of clock. Okay. The second category of the chips, how we use them. The first one was through software, but second one are very targeted. Yes, there will be still some software capability for using them, maybe some configuration, some control, but the whole point is you have a set of hardware in the chip sitting there, inputs come, few outputs are calculated, gone. It's very fast. It's not relying on a lot of cycles of bring from the memory, decode it, execute it, and write it back, and this and that. Okay, but they don't give you much flexibility. FPGA chips is a third type. These chips are already designed and fabricated. You have a finished chip. The first two you need to design and fabricate and all that. These are the chips as a user, as a client, um, as a person developing an application or product. It just use get buy those chips and they already have hardware on it. But beauty is that you can change the hardware. It's not like you can change every transistor connection, but there are some building blocks made with many of those transistors together. And functionality of those, the interconnection of the building blocks and within the building blocks as well as connection of the building blocks to other building blocks can change. Certain wiring can change and certain bits can change, and that still give you a lot of flexibility in the sense that you don't have to create a new chip. You're using that chip for a different hardware now. These FPGAs vendors, suppliers, they provide you a software. So all you do is write a new Verilog or VHDL code. They provide you tools to synthesize them, that code onto that FPGA. The ultimate output is a 01 type of file that you dump on that FPGA and you reprogram that F chip. So it's not a software, it's basically a hardware that is working in a different way. It gives you a lot of flexibility, but again, at the cost of performance, usage of the chip, you cannot just reconfigure everything there. And this is made for certain frequency and all that. And there are constraints, right? So, but it gives a lot of flexibility. So these are different methods, like a CPU, a very targeted one, FP chips that give you a different ways of using these chips. Hope I have explained everything. If there are questions, please leave them in the comments and I'll get to those and I try to reply those. Thank you so much. See you next time. Bye.